My name's Josh McGrath. I started here at UK. I'm up at Lexington back in July, so haven't quite been here a year yet. I grew up in Delaware, so I grew up around a lot of chickens. We've got about the highest poultry density in the United States over in Delaware. I was the soil fertility specialist at the University of Maryland for the last 8 years. So I've got a fair bit of experience with poultry manure and a lot of experience with the EPA and the Chesapeake Bay. How many people know where the Chesapeake Bay is? All right, I'm not here to talk to you about that today, but if you've got questions about that, I can get into that. I'm going to talk a little bit about some stuff that maybe is not quite ready for prime time yet, but things that we're working on. You know, Edwin showed how long manure's been around, and you would think, well, there's not much we can do to improve on manure. It is what it is, but we're always kind of changing things and kind of coming up with new deals. So I'm going to talk about some of the research going into using manure in grain production that might make it even better. So I'm going to start out. This is some of the research that we started on back in 2006. And this was driven by those environmental concerns with the Chesapeake Bay, but they're environmental concerns that are everywhere, but also some agronomic concerns. Edwin talked about nitrogen loss through volatilization. When you surface apply that manure, your nitrogen is at risk for going off as a gas. That's not an environmental issue. It's an economic issue if you're applying that litter for a nitrogen source. So we said, well, if we do some tillage to put it in contact with the soil, and we've got pretty much all no-till where I'm from. It's funny, I travel around the country speaking a lot, and everywhere I go, they inform me that they invented no-till. I came out to Kentucky, and they said, man, we invented no-till in Kentucky. I grew up thinking Delaware invented it. When I got to Maryland, they told me they invented it, and about 4 weeks ago, I was out in Oklahoma at their no-till conference, and there was a guy there from Ohio that said, you're all wrong, I invented no-till, and it was in Ohio. So I actually met the guy that invented it in Ohio. So if he's right, that's where it came from. So we've got a lot of no-till corn production back east. It's just like Kentucky. And we said, well, if we do some tillage, will we get some more nitrogen out and reduce that runoff of the nitrogen and phosphorus? Because we know that when we leave fertilizer or manure on the surface, raindrops in it and run off the surface, they can carry the nutrients right out of the manure. We know that's a risk. We know nutrient losses are higher when it's surface applied. So, you know, what do we gain from a little bit of tillage? And particularly, we were interested in some of the new tillage that was coming out at that time. I saw one sitting out here coming down the lane. How many of y'all familiar with like a turbo till? Vertical tillage, they call it, right? It's basically that disc is a fluted culver that's set straight, and they call it vertical tillage because it just lifts the soil straight up and drops it down, whereas a disc turns the soil over horizontally. So we were saying, well, that pretty much can leave it like no-till, but doesn't give us any benefit. So we did some runoff studies. We set up these plots across the field. You can see we put in some aluminum flashing so that all the rain that hit that field ran off. Now, the highest point in the state of Delaware where I grew up is a landfill. So it's pretty flat over there on the eastern shore, which is a lot like this part of the world, but I mean, even when I get out here, this is mountainous to me compared to where I grew up. You know, I mean, I had one site that we had 1 inch of drop over 2 miles. That's how flat it is. So this field is an extreme slope for the Delmarva Peninsula. It's probably about a 2% slope. So there's how we set up those runoff plots. We spread manure across the whole field at the same rate. Every year it was a little bit different depending on that manure nutrient content. About 4 tons per acre. Putting out the full nitrogen rate because really we're just comparing tillage to tillage. A lot of people kind of throw up their hands and complain and go, well, we don't apply that high a rate anymore, at least back east, and they say, you know, well, you're polluting the environment, putting out that much, but that wasn't our objective. It was to compare the tillages, so we just wanted to make sure we had the same amount between all the tillages. And so what we did was we looked at a chisel disc, which that's kind of our conventional tillage, zone till, and that turbo till, that zone till, we plant on 30-inch corn rows. We're tilling 15 inches with the corn row centered on it. It's pretty popular back home. How many folks have seen a zone till, a ridge till, or anything like that out here? Many? Couple? It's growing in popularity where I'm from. So this is what the chisel disc looks like. Vertical till. There's no till compared to vertical till. After about a week, you can't tell any difference between that vertical till and that no-till if you make one pass. So that was kind of our objective. Can we maintain those no-till characteristics that are beneficial but put some litter in contact with some soil? This is how much crop residue as a percentage is left. If no-till is 100%, which actually is about 60% coverage, but if it's the max you can get is no-till. Turbo-till cuts it about 40%, so does that strip-till. Chisel disc takes it down to about 24%. You're removing 75% of the residue that you have with no-till when you come in with the chisel disc. So here's data from 2006, which was the year we got decent rain. After that, it all went downhill. I swear it's rained every day since I showed up in Kentucky, which ruins everybody's theory in Maryland, because about the first 4 years I was there, it didn't rain, and they said it was my fault. So I can guarantee that it wasn't me that stopped the rain in Maryland. So soil test P was 65 parts per million. That's about 130 pounds per acre, because I know that's how they report it here in Kentucky. One field, 4 replicas, 4 treatments, 3 replicates, same manure rate, same soil test P, same hydrology and slope. Very different results. The management of that manure, how we applied it, had a lot to do with the environmental impact of that manure. No-till and turbo-till, statistically speaking, weren't different. In 2006, there was 20% less phosphorus in runoff. That's phosphorus in runoff, by the way, I would say that. Total phosphorus pounds per acre in that year. In chisel disc, there was a lot less environmental impact. And folks go, well, but what about all the phosphorus in the sediment? But you got to remember, this is a relatively flat field. And it's like Edwin said, he went tear up a no-till field to go to tillage just to conserve some nutrients. These things are site-specific. When you talk about environmental impact, one of the things I think is important to consider is it's site by site. Every field's different. From this, I wouldn't go out and say everybody's got a till. Because if this was in western Maryland, where we got some mountains like you have here in Kentucky, well, the Chesapeake Bay is going to look like chocolate milk. And that's way worse than the little bit of phosphorus coming off those fields. So it's a site-specific type deal. So, of course, what did we do back in Maryland? They changed the law and they made it illegal to do no-till with manure. So in Maryland now, if you apply manure, it has to be tilled in by law. Any kind of manure. It has to be incorporated, injected, or tilled in. And we said, you know, you kind of throwing the baby out with the bathwater because half of Maryland's steeply sloped. But, you know, government has trouble working on site-specific basics because they say, well, we can't tell this guy this is his law and that guy this is his law. But I don't know. There's got to be a better way around it. But so that's what we figured out with the phosphorus. And you say, well, I got invited to the National No-Till Conference. Anybody familiar with that? It's a big meeting from the No-Till magazine. Speak a few years back about this, and I felt like I maybe was the lamb called to the slaughter. I had to go to the National No-Till Conference to talk about tillage and how good it was. And there were some true believers in that room. So I got to walk up in front of a couple, I don't know, 1,000 people or so who were true believers in no-till and tell them that tillage was good in some situations. I made it out alive. I'm here today to tell the tale, so I guess it was all right. But, you know, some tillage does help reduce that environmental impact. But the no-tillers will say, but I get more infiltration in a no-till field. Well, that may be true, but what we saw in our data was, and remember I just showed you 2006. Here's 2006, every single individual rainfall event, and the total peak concentration of runoff. So here's no-till. Look how high it is right after application, right? Turbo-till, it's high after application. But they all, by the end of the growing season, by September, are down around the same amount of phosphorus coming off that field. So no-till was only higher right at the beginning of the season after application, those first couple rainfall events. Now this field, we needed about 2 inches of rain to get runoff in it. Because this is the other thing sometimes folks don't understand. You don't get runoff every time it rains. This field, it took about 2 inches of rain to get runoff, right? And so what happened in 2006? Those first couple rainfall events, even though they were about 40 days after we applied the poultry litter, were over that 2-inch mark. And so we got runoff, and they had a high concentration of phosphorus. Okay? In 2007 and 2008, the first couple rainfall events were below 2 inches, and there was no difference between any of the treatments. So 1 out of 3 years, no-till looked really bad, but it was bad enough that when we looked all 3 years together and came up with the average, it was still worse for all 3 years because of 2 rainfall events that occurred right after application. So that's the other take-home message, that when I talk to farm groups, I'll let you understand there's a disconnect we speak a different language than the folks that are talking about how bad agriculture is, right? I mean, we can all agree we speak a different language. And they misunderstand you, but I think also we misunderstand them. You understand what I'm getting at? And it's important to know that just 2 rainfall events, 2, can make a difference. Now, the next logical question is, well, what am I going to do about that? I don't have an answer for you on that. If I did, they'd probably pay me more. But it's important. There was an impact of no-tilling with that poultry litter, but it was only 2 rainfall events, and it was enough to carry that for 3 years, which is pretty amazing to me how the world works. And you can see this again. This is that first runoff event, 2.08 inches, 41 days after application. 62 days after application, we can't tell much difference between the treatments. 64 days after application, and by the end of the season, there wasn't much difference at all. So, you know, the runoff amounts from the plot seem to be more about the slope and the type of soil. This is runoff amount. Tillage for us didn't make much difference on the runoff amount on these flat soils. And folks always say, well, was that long-term no-till? And yes, it was. So we were tearing up long-term no-till to put it in the tillage plot. You know, and this is what you get in that first rainfall event. If the first couple rainfall events are small enough, they'll put that litter in contact with the soil. We don't have that. It's just like tillage. It puts that litter in contact with the soil. Like everyone was saying, we get the nutrients into the crop where we want it. But if we look there in that first couple of events, if they're big enough to generate runoff, we just get a little bit of litter floating downstream. And that little bit, 1 pound per acre of phosphorus loss is environmentally massive. That's the other thing I always tell environmental folks, because they don't understand that part of the message. Again, we're not speaking the same language. They go, well, the farmers, we're helping them because money's going downstream. 1 pound per acre of phosphate. What's that worth? Very little. It's not money going downstream. It's environmentally significant, but it will cost us more to keep that pound on the field than it's worth. And I'm not making judgment. I'm not saying it's right or wrong, that they're wrong, or this person's wrong. I'm just saying those are the facts. It'll cost us more to keep that pound in the field than to let it go downstream. But that 1 pound has a massive impact on the road. It's just what it is. So I want to talk a little bit about our future research, something more fun. I see everybody starting to grimace at me, and I'm going to have Edwin warm the truck up if I keep going so I can get out of here fast. I didn't have it figured it out. It probably wasn't a good move on my part. So I'm going to try and talk about something a little bit more fun than environmental type stuff, although it has a kind of a win-win thing on that side. So tillage we know is good for keeping nutrients in the field and getting nitrogen and phosphorus into the crop. We know that. All right. But tillage is bad for sediment loss. We don't like tillage in that regard. So what are we going to do? Dairy manure we can inject, right? Liquid manures we can inject. But dry manures to this date we haven't been able to. So the Subsurfer was developed by some friends of mine down in Arkansas at the U.S. Department of Agriculture's Research Service down there in Boonville, Arkansas, to work on pastures, where a lot of poultry litter down there goes on pastures. They started working on technology to figure out if we can inject this manure below the surface even though it's a dry litter. Can we get increased nitrogen efficiency, get more nitrogen in the crop, and therefore get a value out of it that maybe covers the additional cost of injecting? Because you are dragging a bunch of steel through a field. You got to travel a little slower, as you might imagine. So can we get some of that cost back in profit as additional nitrogen into our corn crop? So this is what the unit looked like that they developed. That's actually one of the guys there that worked on it. It's basically a white no-till planter. The researchers have been working on this deal for a while, right? And they're good dudes. I know them all, but I like to pick on them a little bit. They've been working on it. What they've come up with wasn't quite real practical, you know. I think that's highly unusual for university and government researchers to come up with things that are impractical. Do you agree? So, I'm one of them, so I can make fun, right? So these boys here, this is one of them, and they're a hoot, man. I took them out for all-you-can-eat crabs on the bay this summer, and they're a hoot to hang out with. They said, I think we can do better, so I embellished the story a little bit. This might not be true, but I said they got a case of Budweiser and went to the junkyard with a welding torch and came up with a better idea. And sometimes that's where the best ideas come from. And so they took an old white no-till planter, welded it onto this box, and you're basically planting poultry noise, all right? And people say, well, that's pretty small. Yeah, well, we can put it on a trailer and haul it around and do research with it. So it's got these opening discs, It's got these augers in it that pulverize any big chunks or anything that goes through there, and then just like a planter closes it back up. One of the neat things about this is, for folks that are buying litter, all right, where it's costing them money, you can dial that rate in dead on, as you might imagine, by controlling that auger speed. And actually, we have got a rate controller on our tractor that we can sit there, we can vary that poultry manure from 1 to 2. I don't know how much point there is in that, but you can get down to 1/4 ton per acre and up to 6 tons per acre. You can dial that rate dead in. Remember where Edward showed how ununiform surface application is? And a lot of the problem with poultry manure is uncertainty on how evenly distributed it is. And because it's laying on the soil surface, it's not mineralizing all the nitrogen, because the more that litter is in contact with soil, the more nitrogen you get out of it faster. So this kind of dials that in. There's a close-up of what they look like. We've tried with all kinds of different configurations, just like a planter. You can work that out any way you want. There's the augers. This is pelleted poultry litter, which flows through it beautifully. We've got a pelletizing plant up in Delaware that Purdue owns, and it flows through it beautifully because it's a dry pelleted material, as you might imagine. This is some research a friend of mine up in Pennsylvania did, that they saw a yield increase at the same nitrogen rate. They got 100 bushels per acre here and 150 bushels or 140 bushels per acre when it was injected. Now, he's more of a soil environmental scientist. I work more in the ag field, and I told him his problem here was he didn't apply enough. Because if he's losing yield, he could just overcome that by applying 4 more tons, right? Of course, he says, well, that's not the objective. We're trying to be a little bit environmentally friendly, but I'm always thinking on that side of the fence. But, you know, between the two of us, we hit an average somewhere. But this is why. They measured ammonia loss. Here's subsurface injection, no manure, surface applied. Now, that's not much, but it's enough for that yield difference. He was getting 8 pounds per acre nitrogen loss, and actually the injected had just slightly less than no manure applied at all coming off the soil surface as ammonia gas. Makes sense. I'm putting it under the soil surface, it's not going to come off as a gas. Phosphorus loss and runoff, non-existent. If runoff is your modes of transport for phosphorus getting in that river, it eliminates it, right? So the environmental folks all of a sudden are like, huh, we might like this, all right. This is what it looks like running through the pasture ground. Okay? That's a heavy cover crop, wheat cover crop. We can run right through there. You know, it's just a planter, it'll run right through there. Something else that we started thinking about. So these are all the guys that helped develop it right here, these 3 gentlemen here. See that tank that we put up on top of our unit? And I'm bringing this unit down here in a couple of weeks to start doing some work in Kentucky. How many of you have heard of nitropyrin? NSERV, Instinct. It's a nitrification inhibitor. So Edwin showed the nitrogen cycle. When we apply ammonia or urea, the soil bugs start eating it and converting it over to nitrate. Once it's nitrate, he said it can denitrify off the surface as N2 gas or leaks out as nitrate, right? In Maryland and Delaware and most of the Chesapeake Bay region, it is illegal to apply manures in the winter. You can only apply manure after March 1st. Okay? So, which is a good thing because we get, you know, it's a little environmentally friendly, just more nitrogen rate. I think folks would do it up there that way anyway because it's a little different situation here. But we are saying that we need more people spreading litter up there because we got a ton of chickens in a few acres, right? And a lot of folks say, well, I don't take litter from poultry farmers because I can't get across all my ground in time. Only being able to start after March 1st because I got to start planting by April 1st, okay? So we said, well, we want to open up that winter application period. And what NSERV is, Instinct, nitropyrin is a chemical that keeps nitrogen in the ammonium form so it can't leach out. The reason for that law is nitrate leaching over the winter. So we said, the injector provides us a unique opportunity that we don't have with surface application. As we plant that litter in the ground, we can spray it with that Instinct, which is a liquid, and it will preserve that nitrogen as ammonia and get more of it to the plant. It won't go to nitrate, and maybe we can get the government to back off that law and then allow people to start applying in the winter, and then maybe more people can utilize the litter. So we did one field study last year. So I'm going to give the big cautionary statement here. This is 1 year of data under irrigation up in Delaware. Don't hang your hat on it. Again, this is, I'm giving you a taste of things that are coming down the research pipe. But we took that nitropyrin with the injected manure, surface applied litter, and then had it fertilize and control. we put it all out at what we figured out to be about 90 pounds of plant available nitrogen, not total nitrogen, plant available nitrogen up front. At V6, we came back into side dress, 0, 45, 90, or 135 pounds of nitrogen per acre to get the balance of our nitrogen need. We had a 0 nitrogen check that didn't get anything, and then we had a high nitrogen check that got 270 pounds per acre. This is just some calculations of how we figured out plant available in. So what did we find out? Shocking. In nitrogen response work, if you're sufficient, you assume that when you go up to those high rates, you'll converge the yield lines. Remember how I said he lost yield with his surface applied litter, and I told him he should have just applied more? I may have been wrong. Because the deal is, we usually figure, well, if I apply enough nitrogen, eventually if what's holding back my yield is nitrogen, eventually I may hit max yield at 100 pounds with my good treatment, but I'll still get the max yield at 200 pounds with the bad treatment. That's what we assumed. That's not what happened in this case. With standard poultry litter surface supply, we could not catch the injectant with nitropyrene. Why? I think we had a very wet spring like this spring. We injected that manure, and then it got wet. And we probably had some leaching and some denitrification. Okay? With the nitropyrene, those two things don't happen. So that nitrogen got locked up and held in reserve, kind of in the savings account. The checking account got drained out, and the treatment with the nitropyrene was able to kick some in from the savings account and feed that corn before V6. With fertilizer and surface supplied poultry litter, we lost yield even at the highest rates. So we did some lab work to kind of confirm what we saw. We did it at 2 different moisture contents. So if you look across all the treatments, this is 40% of field capacity, which is a kind of dry soil, the blue line. The red line is 75% of field capacity, which is a little bit kind of good moisture content that you kind of like. And this is nitrate mineralization over time. And so the first thing is wet soil mineralizes more nitrogen than dry soil. And we know that when it's moist, the bugs do more work, you get more nitrogen out of it. But across both moisture contents, this is without instinct, this is with instinct, that orange line. That's nitrate on the axis without instinct. Look how much more nitrate came out in that first 4 to 6 weeks than with the instinct. We still had enough nitrogen there to grow our crop because it was in the ammonium form, which plants can take up, but it wasn't in the nitrate form, which can denitrify and leach. So you see how that instinct worked. And the other thing that we didn't expect, this laboratory study was done at 75 degrees Fahrenheit. Instinct was really designed as N-Serve back in the day for fall application of anhydrous. What it does is it kills the bugs responsible for nitrifying ammonia. And it kind of does like that, kills the bugs, and then the bugs start breeding and recolonate that zone where it was applied. In cold soils with fall application of anhydrous, that zone will stay sterile all winter because it's cold and the bugs don't move around much when it's cold. At 75 degrees, our expectation was to have a couple of weeks of control. If you look at this, we had control up to about 8 weeks, beyond what we had with the standard treatment. And that really blew us away. And I think the reason why the instinct works better with manure than fertilizer that it was designed for is that organic material in the manure probably absorbs like a sponge that instinct and keeps it close to the nitrogen in the manure, if you understand what I'm saying. And so it actually, in our lab work, looks like it'll work better with poultry manure than with fertilizer that they make it for, right? So this is interesting, and the injector is the only means we would have to use something like instinct. And the injector already has some other benefits tied to it. But anything that sounds too good to be true, we know what that means. It probably is too good to be true. These are those augers down in the bed. If you look at what's happening to that auger, it's all tore up in the back of the spreader. Why is it doing that? See this big channel right there? See those air pockets in that manure? And that's pretty dry manure. So what's happening? Those augers were standard pitch augers. And when they turn, they drop manure in from the back and pass it under all the litter to the front. Because of that pressure, the weight of the manure down on it, it's kind of squeezing what little moisture is out of it, creating a tunnel, and pretty soon you have augers that aren't flowing any litter. And so when you come back, you've got corn rows that are yellow because there's no way to tell if this thing's dropped to the ground. It doesn't have a red ball system on it. I can't tell if that auger's putting out litter or not. right? And I'm telling you, I've shoveled this thing out more times than I want to. I'm cracking rib in there trying to shovel it out. We've done everything that you can imagine trying to fix this. And so we came up with something that worked for this unit. We put in a variable pitch auger that starts narrow, goes wider, so that it feeds litter from the whole length of the auger at the same time. And this is why a screw can grab into wood, right? Because a screw is a variable pitch screw. And so just like that, with that variable pitch, this works. But this is an expensive, heavy piece of equipment, and your width is limited to the number of augers that you want to drop in. So there are still limitations, even with the variable pitch auger, okay? But I think for some people it'll work right. One of the reasons that it kind of fell apart, when that starts kind of tacking litter around it, that's how those augers, I've ripped these things completely out, I've blown hydraulic motors off of and everything, because as that litter starts to pack around there, that auger starts bending up like this. And when you've got a great big old hydraulic motor on that auger, stuff starts happening that you don't want to happen when you start getting litter packed around it. But down where this was developed was Arkansas, where they have rice hulls for bedding material. And at first we thought it was moisture content. It's not. It's the physical characteristics of that litter. We use wood chips up where I'm at, wood shavings. And it just has a different consistency. It's not moisture content. So with rice hulls, it seemed to work. With the wood shavings, it didn't. It tears those things up pretty bad. So we said, all right, time to pack a lunch. We got to go to work. So we started thinking on it. This is out in Oklahoma. I don't want to show you the guts of it because I'm not sure that's what the guts will end up looking like. But this guy right here is an ag engineer out in Oklahoma, Randy Taylor. He's a pretty fun guy to work with. And what we've got here, you see them hoses coming off there? We're working on an air seeder design. We want to kill about 3 birds with 1 stone. We know the augers now with the variable pitch will work, but we still are limited in width and speed of covering that field. So we started thinking, how can we get a 30-foot boom that folds out just like a big planter? Can we move poultry manure with air? And we sat there tossing around, we agreed we were going to try it. And a couple months later, Randy called me up and he says, you know what? It ain't going to work. And then I didn't hear from him for about 3 more months. He says, I've started working on it. I figured the only way to prove it doesn't work is to prove it doesn't work. So then I went out there the first week of March, and this is what he had. It's just a little prototype. The muncher's inside this box. He's got a great big old fan there like you got on a planter. And he can take those hoses and blow poultry manure over top of that building. So we can move that litter with air. We're still working on the design of the muncher because I've found monkey wrenches, crowbars, hammers, boots, everything you can imagine in poultry manure. So we're trying to bulletproof that muncher so that when the litter goes through it, if a monkey wrench falls in there or a concrete block, it's okay, right? So the idea is to make this into a toolbar that you can put on the back of your existing spreader. Because our existing spreader is that belt or that walking floor, depending on what you got, at work. And if we can make a toolbar, you can just take your beaters off, purchase this unit, put it all behind your beaters with your fold-out booms and let it run. We're a couple years away from making this work. We hope by the end of the summer to have a prototype that we can do some plot work with just to see how it goes. Other thing that some other folks are working on is some stuff like they replace those augers with a walking floor. And that works great. And then put the augers up front, put a shorter throw on those augers. It makes for a lighter and actually cheaper piece of equipment with a less energy demand on it. So we're working on some other things too, all in the mix to improve this unit. But the ultimate goal is to get something we can inject manure with in a no-till system, eliminate phosphorus runoff, conserve more nitrogen, and perhaps with the chemistry of the nitropyrene, really be able to back up that litter application from the time the corn needs it and still have the nitrogen there for the corn. So, you know, it comes down to those 4 R's, controlling rate, timing, and placement, and this source side is the stuff like nitropyrene, the N-Star, trying to get that worked out. But this 4R approach to nutrient management, whether it's fertilizer or manure, I think these combinations of technology will get us more bang for our buck out of the poultry manure. And the agricultural community can go forward to the environmental community and say, we are working, we know that we have shortcomings, but we're going to have chickens because people want to eat chickens. And if we're going to have chickens, we're going to have poultry manure. And we're going to be the ones that come up with a solution to make it even more environmentally friendly than it is now, right? So that's kind of the objective that we're moving forward with this. There's my email address and my Twitter handle if you do that. If you have any questions, I don't know how much time I have, but I'd love to talk to you about anything you want to talk about. Almost anything. Questions? I talked too fast. No one heard anything I said. Something about an injector of manure, right? Well, and if any of you ever want to try out the poultry litter injector, we're going to have one down here in Kentucky by this fall.